Yes, hello folks, we are back with the part 8 video of this exercise 5.5, and these are, you can have some sigh of relief here. Some quite easier problems have come up. Now this problem, x raised to y plus y raised to x is 1, and the next problem is x raised to y equal to y raised to x. They take the same flavor, almost the same kind of working. Actually this problem is simpler than this problem, so I think this should have come first. Once you get thorough and good about it, it is easier for us to do this problem, but I don't know why in the textbook they have put the other way around. So for our convenience, we'll do one thing, we'll do that first, then we'll come back to this. So that it's easy to work, you feel comfortable to work like that. So though we are doing both the problems, we are doing it in a little topsy-turvy order, just for us to get ourselves comfortable, right? So see, one advantage of this problem is it is equal to. So whenever you have equal to, problems are much more easier. Always check. We're doing it for the first time. We have not had such problems till now, but whenever you have this equal to kind of problems, they are much more simpler, and it's much easier to do such problems. So we start right away, but when we observe that the left hand side and right hand side is both function raised to function. So direct derivative is not possible. First we will go in for a log on both sides. So let's take a log on both sides. Log x raised to y is equal to log y raised to x. So what do we get? Exponent will come here, we know. It is y times log x is equal to x times log y. We all know that we are doing all this to get the derivative. So automatically our next step is to get the derivative. So let's take the derivative. Derivative of x for this y log x, and derivative with respect to x for this x log y. Nothing new to us. It's a product function. So we know how to take the derivative of a product function. First y as it is, derivative of log x, then log x as it is, derivative of y. On the right hand side, x as it is, derivative of log y, then log y as it is, derivative of x. So what comes? Y times derivative of log x, we know is 1 by x. Then log x as it is, dy by dx has to be dy by dx, nothing much that we can do. Then x times derivative of log y is with respect to x. So log y with respect to y is 1 by y. Because it is with respect to x, we have to write dy by dx also. This is log y, and derivative with respect to y, x with respect to itself is 1. So if you want you can write, or else leave it. So this is now y by x plus log x times dy by dx equal to x by y dy by dx plus log y. So as usual, dy by dx terms on one side, non-dy by dx terms on the other side. Let's see how that will work. So the dy by dx terms on one side and the non-dy by dx terms on the other side. So you will have probably this coming here. So already we have log x dy by dx minus x by y dy by dx is equal to the non-dy by dx terms. So which are the non-dy by dx terms? It is so what we have done, we have taken this here, so automatically this term has to come here. So we have a log y already minus y by x. So what is happening here on the right hand side, left hand side, dy by dx is common. You are having log x minus x by y, and here we have log y minus y by x, and it calls for a little bit of equalizing into y, here into x. So what will come? Dy by dx times y log x minus x whole by y, and here it is x log y minus y whole by x, like that. What happens to dy by dx is a product, so it goes there, it gets divided. So it is x log y minus y by x whole upon y log x minus x by y. You can just rearrange. So what will happen? Divided by means multiplication by the reciprocal. So you can have x log y. So this goes in the numerator. So like you could have this rearranged. This will go to the numerator and this will go to the denominator. So it will become y by x log y minus y by y log x minus x. Yes, right. So sometimes I don't know. If I vaguely remember that in some of the board papers they had asked this problem as prove that, prove that dy by dx is like this. These are important questions actually. Everything in the exercise is quite important. You can see that these problems in the exercise off and on had been asked. Logarithmic differentiation during time when there was a 4-mark question, probably always logarithmic differentiation would be considered because there is work there to do, right? So that's about it. So maybe with this backdrop that would become a little more simpler to do. So let's get across with that problem now. We have done it a little topsy-turvy, 13 first and then 12 later. It's okay. X raised to y plus y raised to x is 1. So because that plus is there, we know that overall logarithm is going to be a little difficult. So we will do one thing. We will take the derivative on both sides first to start with. Okay, or you could do one thing. You could call this as u and then you could have worked. You call this as u, call this as v, get the derivatives and then come back, and that way also it's okay. So maybe we will do it like that because we will not change our trend. Let u be x raised to y. There's no need to call y like the earlier problems because y is already there, isn't it? Earlier problems y was not there, so we were bringing that y into the picture. Now y is already there, so that y step is not required. So we are calling the first term as u and the next term as v. Right, so you have got v as x raised to y, u as x raised to y and v as y raised to x.